Hey guys, afternoon everybody. Could you just let me know if you can hear me before I start, please? All right, great. All right, so I'll get started right away. So what I'm going to be doing today, guys, I'm just going to do a free session. We're going to look at wording fraction problems. All right. So feel free to share this link with any of your friends that are preparing to write the SEA exam next month. This session could be useful to you. Okay. Um, so let's start with some very basic type questions first before I get to the heavy stuff. All right. So we have a statement here, and we want to fill the number that is missing in this box here. Okay. So we have 3/8 is equal to something over 32. This one should be easy for you guys. Could you put the answer in the chat for me? What do you all think the answer is for this question here? All right, so I've seen some answers coming through. Those answers looking correct. So this is what we call equivalent fractions here. So 3/8 can be written as something over 32. Now what you need to do, you need to look at these two numbers at the bottom here. How can I go from 8 to 32? But what you need to remember, we're going to multiply or we're going to divide in order to get that equivalent fraction. So for example, if I were to say 8 multiplied by 4, I'll get 32. And whatever we do on top here, right, has to be the same that we did at the bottom. So you're going to multiply by 4 as well, and we're going to get 12. So 3/8 can be written as 12 over 32. All right. So this is a very basic question that could appear in section 1 of the exam. Let's look at this next one here. This is something that they bring in section 1 as well. Expressed as an improper fraction. So we have 5 and 2/3, and you want to express that as an improper fraction. Now, how do we do something like that? So if you have 5 and 2/3, and you want to represent this as an improper fraction, what we do, we say 5 multiplied by 3, right? Sorry, multiplied, right? So 5 by 3 is 15, and then we're going to add this 2. So that is actually going to be 17 over 3. So this is how we're going to convert a mixed number into an improper fraction. Again, this could appear in section 1 of the exam. Now, the focus on the session today is on more advanced problems. All right. So I'm just giving you these basic ones here just to kind of get a feel for some fractions. What about this one? They can also ask us to take an improper fraction and write it as a mixed number. How can we write this as a mixed number? Okay, so a lot of correct answers there. So we have 35 over 6. So this here is an improper fraction, and I want to write this as a mixed number. So what we're going to say is how many times can 6 go into 35? All right. So in this case here, right, 5 can go into 6 can go into 35 5 times, right? Because 5 6 is a 30, and we're gonna get a remainder of 5. So in this case here, we are going to get 5 and 5 over 6. Okay. So again, this is one of those simple questions that can come in section 1 of the exam paper. Okay. All right. So I'm glad you all are responding in the chat. That's great. Now let's get to some real type of questions here. So Ajay has $480. 5/8 of his money is equal to 3/5 of Shalini's money. How much money does Shalini have? Now, for a question like this here, read the question and try to understand what is being given here. So we have Ajay, and Ajay has $480. Now, 5/8 of Ajay's money. So what I'm going to do, I'm going to work out 5/8 of Ajay's money. Okay. So that'll be 5 over 8 multiplied by 480. So let's multiply this here now. So this 8 can go into 8, 1. 8 can go into this 6 8s are 48. So this is 60. And then 60 multiplied by 5, that's going to give us 6 out of 30. So this is going to be $300. Okay. So 5/8 of Ajay's money is $300. Now this amount here is actually equal to 3/5 of Shalini's money. Now I'll show you how to do it quickly here, but visually I want you to understand what we have here. Let's use this rectangle here to represent our whole. And since we are dealing in fifths, let's divide this into 5 equal parts. 1, 2, right? So these are 5 equal parts here. So every single one of these here represents 1/5. All right, now this $300 here, they're saying that that is equal to 3/5 of Shalini's money. So this here is Shalini. All right, and what we're saying here is that $300 is equivalent to 3/5. So 3 of these blocks here, right? 3 of these blocks here is actually equal to $300. Now you want to work out how much does Shalini have. So what you can do, you can figure out for one block. So one block is simply going to be 300 divided by, now remember you have 3 blocks here. This is 3/5. 1, 2, 3. So you're going to divide that by 3 here. So that's going to give you $100. Okay. So one block is equal to $100. So Shalini, right, actually has, since one block is 100 and we have 5 blocks in total, we're going to say 5 multiplied by 100, and that's going to give you $500. Now this is visually what's happening here. This is visually what's happening here. But when you're in the exam and you are trying to work this out quickly, one fast way of working this out here is to do this. So for Shalini, right, since you know 300 is equal to 3/5, if I want to get the whole, all I need to do is to invert the 3/5. So put 5 over 3, and you're going to multiply it by the $300. In which case 3 into 300 will be 100. 100 by 5, you get $500. Okay. So if you are in the exam and you want to move quickly, my suggestion is to go this route here. But visually, I want you to understand what's happening. Okay. Let's have a look at the next one here. So Patrick picked 320 limes. He sold, change this word here. Right. He sold 5/8 of the limes. The remainder was packed in bags, and each bag contains 12 limes. How many bags was he able to fill? So this is our starting amount here. We have 320 limes, and he sold 5/8 of the limes. Okay. So again, let's use this block here to represent our whole. Now 5/8 are sold. So we have 5/8 here. So if he's selling 5/8, it means that your remainder is going to be 3/8. So 5/8 is what is sold, and this is what is left. All right. Now the remainder, right, is packed into bags. The remainder is packed into bags. Now some students, what they may do, they may work out 5/8 of the 320. they'll get an answer, and then they will subtract that from 320, but that is extra work. If you can recognize that, here what? If he sold 5 eighths, it means that what he's left with is 3 eighths, okay? So the remainder, we can actually work out the remainder directly. So the remainder is simply going to be 3 eighths multiplied by 320. All right. So 8 can go into 8, 1 here. 8 could go into 32 4 times. So this is 40. So 40 by 3 will give us 120. So this is the amount of limes he has remaining, 120 limes. Now the remainder now, which is the 120, is packed into bags, and each bag contains 12 limes. We want to know how many bags was he able to fill. So the number of bags is simply going to be, he has 120 limes to pack, and we know that in each bag we place in 12. So therefore, he's able to fill a total of 10 bags, right? So I see some of you all working it out quickly. So great, right? Right. So I'm happy that in this session here, we see a lot of people answering the questions, right? Please don't old talk and waste time in the chat. Try your best to see if you can answer the question. Okay. So yes, it is 10 bags. Let's try next one here. Tickets at a school event cost $65 for an adult. A child ticket costs 2/5 the price of an adult ticket. What is the total cost for 2 adults and 3 children? So we have tickets here being sold. So we have adult, right? And the adult ticket is $65. The child ticket is 2/5 the price of an adult ticket. So therefore, we have to say 2 over 5. And we're going to multiply that by 65. Okay. So again, right, 5 can go into 5, 1. Right, 5 can go into this 1 time, remainder 1. So this is going to give us 13 here, right? So 13 by 2 will give us 26. So therefore, the cost for a child ticket is $26. So that's step 1. We need to figure out what's the price of a child ticket. Now, what's the total cost? So we want total cost, but we have 2 adults and we have 3 children. So 2 adults is simply going to be equal to 2 multiplied by $65, right? Now, again, all of these things here, you can do this in your working column. So it's 65 by 2. So 5 2s are 10, 6 2s are 12, and 1 13. So therefore, the cost for the 2 adult tickets here will be $130. Then we have 3 children. So to work out for 3 children here, we'll say 3 multiplied by 26. So again, working column here. So 26 multiplied by 3. So 6 3s are 18. 2 3s are 6 and 1 7. So that's a total of $78. All right. Now we want the total cost for this here. So all we need to do, we need to add up these 2 figures here now. So 8 plus 0 is 8. 7 and 3 is 10. So that's going to be $208. All right. Excellent job, guys. I seen you all putting your answers in the chat. Great. Let's try next one here. So Rebecca went to the supermarket with $180. 2/9 of her money was spent on chicken. 3/7 of the remainder is spent on potatoes. How much money, right, does she have left, right? Or how much money is she left with? So this here represents the starting amount. She has $180, and she's spending the money on 2 things. She has chicken, and she's also purchasing potatoes. So in the case of chicken, right? Chicken will be 2/9, right? Now, actually, you know what? We can do this a little simpler. All right, so let's gonna draw something here to represent our whole, right? So this represents the money that she has at the beginning. Now, 2/9 is spent on chicken, right? So let's put 2/9 here. So if she's spending 2/9 on chicken, right? And what you're left with here now, if you spend 2/9, it means that she has 7/9 left. Okay, that's the remainder she has. Now, 3/7 of that remainder now is spent on potatoes. So now what you're doing here, this blue box here, right? This blue box here represents the amount that is spent, or that is the remainder, right? That blue box is the remainder here. Now, 3/7 of that now is being spent on potatoes. So therefore, 3/7, right? Let's break that up here. So this here is your potato. Okay. So if that's 3/7, then what you're left with is 4/7, right? Now, how much money is she left with? Okay. So what I'm gonna do here, right? What I'm gonna do here, we can say for the chicken. Now there are multiple ways you can work this. So for the chicken, she spent 2/9 multiplied by 180 over 1. So this 9 into 9 is 1. This will be 20. So she spent $40 on chicken. All right. Now the remainder now is simply going to be 180 minus 40. So she has $140 left now. Now we are saying that 3/7 is spent on potatoes, okay? But this here, this 4/7 here is what she's left with. All right, this 4/7 is what she left with. So we can go directly and work out what she's left with by simply finding 4/7, right? Multiply by your remainder. You see, this remainder here, right? This corresponds to your $140. So all I need to do is to find 4/7 of 140 over 1. So 7 into 7 is 1. 7 into 140 will be 20. So 4 2s are 8. So this is going to give us $80. All right. Which is what you guys are getting, which is great, right? There's $80 that is left there. Awesome. Let's try next question here. Aidan spent 2/5 of his salary on rent and 4/5 of his money on food, right? Let's change this word in here. And the remainder of $250 was saved. What was his salary? So we have, let's use a little diagram here to help us visualize this. All right, so let's say this box represents his whole, that's his salary here. Now 2/5 is spent on rent. All right, so 2/5 is spent on rent. All right, 4/15, right, is spent on food, right? And this remainder here, right, this part here is what he is saving, right? So this is his savings here. And we know that this figure here actually corresponds to $250. Okay, that's what we know. So what I would do, I would try to figure out what fraction does this correspond to. Okay, so now we have 2/5 and we have, so let's write down for rent. Rent is equal to 2/5, but let's write that as an equivalent fraction. Let's write that as something over 50. So if you want to write this as something over 15, we're going to multiply this by 3. So you'll get 15 at the bottom here. And let's do the same thing on top. Multiply by 3 as well. So 2 by 3 is 6, right? So the rent is actually 6 over 15. His food is actually 4 over 15. All right? So what we have here, this total here will be the total fraction for food and rent. Okay? So food and rent is going to be equal to 6 over 15 plus 4 over 15, which is 10 over 15. Right? You can reduce this if you want. That's fine. This will be 2 5s are 10. So that's 2/3. Okay? So that means for rent and food, he spent 2/3 of his salary. So the fraction left, right? The fraction left, right? Or the fraction saved is simply going to be 1 minus 2/3, which is 1/3. Right? Now that 1/3 there is equivalent to $250. So if you want to work backwards and work out his salary, so the salary is simply going to be, so if 1/3 is 2/5, I'm sorry, $250, then all we need to do is to say 3 multiplied by 250, right? And we're going to get $750. Right? So again, excellent job, guys. I've seen everybody getting 750. That is great. All right? So it seems like you're all ready for next month, man. All right, let's see this one here now. So Pauline sells Portugals in the market. 3/5 of the Portugals was sold before lunch, and 1/3 was sold after lunch. At the end of the day, she had 36 Portugals left. How many Portugals did she have at the beginning of the day? All right. So Pauline is selling Portugals here, right? So draw a diagram here so I can visualize what's taking place. Right, so this Portugal, this represents our whole, that's Portugals, right? So before lunch, she sold 3/5. Right? So that's before lunch, right? So this is what she sold in the morning. So that's AM in the morning. All right. And 1/3 was sold after lunch. All right. So after lunch, she sells 1/3. So that's in the afternoon. Let's call that PM. Okay. And then what's happening here is that this here, this fraction here represents what is left, right? So this is what is left. But what is left here is actually 36 Portugals. Okay. So we want to figure out how many Portugals did she have at the beginning of the day. So morning, right? So in the morning she sold 3/5. All right, now what I need to do, I need to add up the 3/5 plus the 1/3 here. So the LCM of 5 and 3 is going to be 15. So let's write this as an equivalent fraction as something over 15. So let's put 15 here. So if you want to write 3/5 as an equivalent fraction, we have to multiply this by 3. And whatever we do at the bottom, we have to do the same thing at the top. So you're multiplying by 3 as well. So in this case here, 3 by 3 will give us 9. All right. So in the morning, she sold 9 over 15. And in the afternoon, right, what is happening here? We have 1/3. So let's write 1/3 as an equivalent fraction over 15. So in this case here, we'll say 3 by 5 will give us 15. We do the same thing on top, right? Multiply by 5. So 1 by 5 will give us 5 here. Okay. So now I know the fraction that we have in the morning, which is 9 over 15. I know the fraction in the afternoon. So the total sold or total fraction sold is simply going to be the morning fraction, which is 9 over 15, plus the afternoon, right? So 9 and 5 is 14, so that's going to give us 14 over 15. So therefore, what she's left with, so the remaining, right, is simply going to be the whole, which is really 15 over 15, right? That's your whole, minus 14 over 15. So we're going to get 1 over 15. All right, so that is the fraction. That is the fraction that is left. Now we're trying to work out the total amount of Portugals at the beginning of the day. So 36 Portugals is actually equal to 15. So the beginning, right? All we need to do, we have to invert the 1 over 15. So that's 15 multiplied by 36. So this is all I need to work out, 15 by 36. So 15 multiplied by 36. So 6 5s are 30, right? 1 6 is 6 and 3 9. Put a 0 here. 5 by 3 is 15. 1 3 is 3 and 1 4. Right? We add this. So this is 0. 9 and 5 is 14. Right? So we're getting 540 here. Right? I'm getting 540 Portugals at the beginning of the day. Everybody good? Right. Let's look at the next question here now. A supermarket purchased 720 packs of milk. 1/3 of the packs of milk were vanilla flavored. 3/5 of the remainder was chocolate flavored. The remaining packs of milk were strawberry flavored. Calculate the number of packs of strawberry flavored, right? All right, so let's see how we're going to do this here. So we have 720 to begin with, right? 720 packs. Now 1/3, right, of the milk is vanilla flavored, right? Now let's just draw a diagram here. All right, so 1/3 is vanilla. So 1/3, right? So 1/3 here is vanilla, right? So if you have 1/3 there, that means that the remainder is actually 2/3. Now this 2/3 here now is made up of both chocolate and strawberry. So this block here is made up of chocolate and strawberry. So 3/5 of the remainder. So this here is 3/5 of the remainder. This will be 2/5 of the remainder. So this 3/5 of the remainder here represents chocolate. Right? And this one here, that 2/5 of the remainder represents strawberry. All right. Now, once I understand what's happening here now, it's easy to work this out. Okay, so let's work out. So if I had to work this out here, I could work out the remainder, right? I could work out the remainder first if I want. And to get the remainder, all I need to do is to say 2/3 multiplied by 720, right? All right, so 3 can go into 3 one time here. This will be 2 3s are 6, remainder 1. So this will be a 12. All right, so this is going to be 4 0. So that's 240 multiplied by 2. So that's going to give us 408. So that represents, that's the remainder there. That's 2/3 of the 720. That's your remainder. Now the thing is, the strawberry flavored only accounts for 2/5. So for the strawberry, we're just going to take 2 over 5, 2/5, and you're going to multiply that by your 480. right? So 5 can go into 5, 1. 5 can go into 48. That's 9 5s. 9 5s are 45. Remainder 4, right? Sorry. Remainder 3, right? So this will be 30, right? So 5 and a 30 will be 6, right? So that is, sorry, this is 9 here, my bad, right? 9 5s are 45, right? So that's 96 by 2. So we just need to work out 96 by 2. 6 2s are 12. 9 2s are 18 and 190. Right? Right? Somebody says, right? I see you all asking about strawberry. Yeah, the number of packs, right? Yeah, number of packs, 192 packs, right? 192 packs, that's fine. All right. So normally in the exam, you'll see they will put they'll have a line at the end here, right? And they'll put something like this, and you just have to write down the answer. So please use this here to write your answer in the real exam. Okay, please use that. Right? Double check that, Nathan, right? But 2/5 of 480 will give us 192, right? All right, let's try a next one here. All right, let's try a next one. At a bake sale, at school, the teachers sold chocolate cakes, vanilla cakes, and sweetbreads. 3/8 of the cakes were chocolate cakes. 2/3 of the remainder were vanilla cakes. If there were 45 sweetbreads, how many vanilla cakes did they have? All right. So let's have a look at this one here, right? All right, so we have a bake sale, and we have chocolate cakes, we have vanilla cakes, and we also have sweetbreads. Okay. Now, 3/8 of the cakes were chocolate. So let's do a little diagram. These diagrams are very helpful to visualize the fractions. Okay. All right. So this here represents the whole, all the cakes, well, all the cakes and the sweetbreads that we sell in here. All right. So 3/8 were chocolates. So 3/8. All right. That represents our chocolate. Right? So if you have 3/8 there, that means that the remainder is going to be 5/8. That's the fraction that is left. Okay? Now, the next part here says that 2/3 of the remainder. So, all right, let's draw an X box here to represent the remaining part. So this here is the remaining part. But 2/3 of that remainder is vanilla. So if this is 2/3 here, this fraction here corresponds to vanilla. Right? And then if that's 2/3, it means you have 1/3 here. Okay? So now, if there were 45 sweetbreads, now this last piece here, that's your sweetbread, right? All right, now let's say, right? Let's say that the number of sweetbreads we have is 45, right? So that remaining part there is 45. So we want to work out how many vanilla cakes do we have. Now the thing is, what we need to do, we need to first figure out what's the total. How many baked goods do we have at the beginning? That's what we need to figure out. Now the thing is, if the sweetbread here corresponds to 1/3 of the remainder, so here's what I would do here. Sweetbread. Let's work out what fraction does sweetbread correspond to. So you have 1/3 of the remainder. So that's going to be 1/3 multiplied by 5/8. So that is going to give us 5/24. All right. So that is going to be, right? That is going to be the fraction of the whole that represents sweetbread. But remember, that corresponds to 45. So the whole, so we need to work out the whole here. If you need to work out the whole, we just need to invert this fraction. So that's 24/5. And you're going to multiply by the number of sweetbreads that you have, which in this case is 45. All right, so 5 into 5, 1. 5 into 45 is 9. So we just need to work out 24 multiplied by 9. So 9 4s 36. 2 9s 18, 19, 20, 21. So therefore, this here represents the total number of baked goods that we have at the beginning, 216. All right. Now, that's not what they asked us to work out. They want us to work out the number of vanilla cakes. All right. So if I work out vanilla, so what is vanilla? Vanilla is actually 2/3, right, multiplied by 5/8, right, which is going to be 10/24. So the fraction of the whole that corresponds to vanilla, right, vanilla cakes, is going to be 10/24. So the number of vanilla cakes, right, is going to be 10/24 multiplied by 216, right? So we need to work this out here. All right. Now, what I normally tell students to do, if you are having trouble multiplying this out, 10/24 by 2/16, let's see what can go into what here first, right? First of all, this fraction here could be reduced. So this could be 5 and this could be 12, right? Then we need to see how many times 12 can go into 260, right? So 12 and 12 is 1. Right, 12 can go into this. This is 1/12 is 12, right? And then we have 21 minus 12, that's 9, so that's 96, right? And this will be 18. So 18 multiplied by 5, that's 8 5s are 40, 1 5 is 5, and 4 is 9. So this here will work out to 90 vanilla cakes, all right? Does that make sense? All right. As a reminder, for those of you who are watching live here, please remember to hit like and subscribe to the YouTube channel, right? So please remember to do that when you can. All right, some people say easier than they thought, right? I've seen some familiar names in the chat here. Can you do angles? When you say angles, what you mean? The only angles you guys have to know are things like 90 degree, acute angle, obtuse angle, reflex angle, all right? All right, let's see. If I finish the questions that I have here, all right, I might do some more stuff. We'll see. All right, let's see what's happening here now. Keisha baked cupcakes for a sale. 5/9 of them were chocolate and the rest was strawberry. She sold 4/5 of the chocolate and 3/4 of the strawberry. She had 24 cupcakes left. How many cupcakes did she bake for the sale? Again, a lot of students, they read this, but they're not visualizing what's happening here. I teach a lot of older kids as well, right? And the best thing to do is to draw little diagrams to help you visualize these things. So in this case here, that's what I'm going to do. So Keisha baked cupcakes. So I'm going to use this rectangle here to represent my whole. So this will represent all our cupcakes that she's baking. Now they are telling us here now that 5/9 of them were chocolate and the remainder strawberry. So let this represent our 5/9 here, right? Now this represents chocolate, right? And if that is 5/9, it means this is 4/9. And that represents who? Strawberry. All right. Okay, so this is what we have here. Now, she sold 4/5 of the chocolate. So now I'm going to draw an X box here now. So this box that I'm drawing here represents a chocolate, and she sold only 4/5 of that. So this here will be 4/5. And if that's 4/5, it means she kept back, or she did not sell, right, 1/5. So this here represents sold, right? And this represents what's left, right? So that's the fraction that is left here for the chocolate. Now, with respect to the strawberry now, what's happening to the strawberry here? Right, 3/4 of the strawberry, right, was sold, right? So I'm going to draw an X box here to represent my strawberry. And 3/4, right, 3/4 was sold. So that means that this fraction here, 3/4, would be sold, and therefore what you're left with is a quarter, right? So this here represents what is sold, and this here represents what is left. All right, so you have sold, you have left. Now, what we do know is that we have 24 cupcakes left. So what I need to do here, if I could figure out what fraction of the whole is left, then I could work out how many cakes we had at the beginning. Okay, so let's look at the chocolate left. So this is what I would do. Work out the chocolate left. Now the chocolate left here will be 1/5, right, of your 5/9. All right. So this is going to be 5/45. So this fraction here represents the fraction of the whole of the chocolate that is left. So the next thing we're going to do, I'm going to work out the strawberry that is left. All right, so the strawberry that is left is a quarter multiplied by 4/9, right? Make sure I'm watching that correct here, right? Yeah, so that is going to give us 1/9, right? I hope that kind of making sense. All right, so that is 1/9, right? Now I want to work out the total fraction that is left, right? So we have 5/45, that's for chocolate, and we have 1/9. But the thing is, let's write this 1/9 as something over 45. All right, let's get an equivalent fraction here to allow us to add these things easier. So this is really 9/5 will give us 45. So we have to do the same thing on top. So we have to multiply by 5 here. So therefore 1/5 will give us 5. Right? That looking correct? Make sure. Oh wait, that's now. 1 second. Why did I do that? Give me 1 sec, right? I realize I'm making our life complicated, right? 1/5 by 5 over 9 here will give us 1 over 9, and this will also give us 1 over 9, right? So much easier than I'm complicating the problem, all right? So basically we have 1/9 of the total left as chocolate and 1/9 left as strawberry. So the total left is simply going to be 1 over 9, that's the remainder of the chocolate, plus same 1 over 9 for remainder of the strawberry. All right, so that's going to give us 2 over 9. That's the fraction that is left. Now that fraction there corresponds to 24, right? So therefore, cupcakes, or total cupcakes at the beginning, all right, all we need to do is invert that 2 9s. So that's 9 over 2. And you're going to multiply that by the 24. That's what's left, okay? So 2 into 24 is going to be 12. So 12 by 9 is 108. Right? I didn't see anybody work this one out. Y'all having trouble with this one? Some people asking about the session. It'll probably be about an hour or 1:15 around there, maybe. Right? If anybody else worked it out, let me know if you get 108. Let's try something else here. A cinema has 600 seats. 7/10 of the seats were occupied, and 2/3 of the audience were adults. If 3/5 of the children who were in the cinema were boys, how many boys were in the audience? Okay, now don't get scared when you see questions like these, right? Look at what is being asked. So we have a cinema. It has 600 seats, okay, but 7/10 are occupied. So again, I like my diagrams to see what's happening here. So in this case here, we have 7 over 10 of all the seats being occupied. So let's put 7 over 10 here. So therefore your remainder is 3/10. So the 7 over 10, right, is occupied. Meaning that people are sitting in this fraction here, right? And in this one here, right, not occupied or unoccupied, right? Right? Okay, so what else are they telling us here now? So they said 2/3 of the audience were adults, right? So now let's break this up here now into what is occupied. Let's break it up into adults and kids. So 2/3 of the audience were adults. So we have 2/3 here represents adults. So that means that 1/3 will be kids. So this here represents your adults. All right. And this here represents children, right? Now we are also being told that 3/5 of the children were boys, right? So we need to break this piece even further up now. So this block here, so I want to shift this a little bit, right? All right, so let's put this here. This will be children. All right, so what I want to do now, I want to break up that last block here now. The children here now, right? This piece here is being broken up into boys and girls, okay? So in terms of fractions, they said that 3/5 of the children were boys. So this here represents 3/5, and therefore this that is left here is going to be 2/5. Right? So this corresponds to boys, and this here corresponds to girls. Okay. Now once I have this, now I have a visual in terms of what fractions I'm going to be using here. So let's see. So let's work out, first of all, right, the occupied seats, right? So occupied is simply going to be 7/10 multiplied by 600. So let's start with that. All right. So 10 into 10, 1. This will be 60 here. 6 sevens are 42. So that's 142, sorry, 420 seats occupied, right? So now let's work out how many kids we have here. So children, right? The amount of children here is actually 1/3 of that amount. So it's 1/3 multiplied by 420, right? So 3 into 3 and 1, and this will be 1, 3 is 3, remainder 1, so that's going to be 4. So this is 140, right? So this here represents the number of children that we have here. The next thing we want to work out the number of boys. So if you want to work out the number of boys, the number of boys is simply going to be 3/5 of what we have here. So this is going to be 3/5 multiplied by the 140. Right? So 5 into 5 is 1. This here will be 2 5s at 10. And that's a remainder of 4. So this is going to be 8. So we need to work out 28 multiplied by 3. Right? Unless I seen you again 36. Did I have an error somewhere here? 1/3 multiplied by. Right? So one thing you all need to understand is that there are multiple ways of working problems. I see you all saying you got, for the previous question, you got 1 or 8 using a different method. That's fine, you know. That's fine. Right? They are not looking for the exact same method to work out all of these questions, right? Right? So I'm seeing some of you all have different answers. Anybody else got 84? Some people get 36, right? I'm not sure how you all got 36. All right. Okay. So, all right. People saying 84. Yeah, 84 is the correct answer here. Okay. You see, when you have a diagram like this helps you tremendously when you have fraction questions, right? Okay, great. All right, great. All right. All right, so let's have a next question inside here. So Priya uses colored beads to make handbands and necklaces. 1/3 of the beads are used to make handbands, and 5/6 of the remainder is used to make necklaces. She had 20 beads left over. How many more beads did she use to make necklaces than handbands? Now, again, these questions, when you read it the first time, they seem very tricky, right? They do seem very tricky. So she's using colored beads here to make these handbands and necklaces, all right? So let's start off with our hole, which we don't know what it is, all right? So this here represents my hole. And she's using this to make handbands and necklaces. So 1/3 of the beads are used to make handbands. So 1/3 is used for handbands. So that means 2/3 will be used for, oh no, hold on. Yeah, right? So we have 2/3 left here. So this here, this first part here represents our handbands. right? That's the wanted part here. Now, 5/6 of the remainder is used to make necklaces, right? 5/6 of the remainder is used to make necklaces. So not all of the 1/3 here is being used for the necklaces. So we're only taking part of this here to make the necklaces. And that's 5/6, right? So 5/6 here, right, is going to be used for your necklaces. And if you're using 5/6, it means that 1/6 here is going to be left. So this here will be your remainder, right? Or let's put left, right? I think I call it left. Any question? All right. Now, we have 20 beads left over, right? We have 20 beads left over. How many more beads did she use to make necklaces than handbands? Okay. Now, we can do this in several different ways. What I can do, since I know how much she has left, I can actually work out what's the total number of beads she started off with, right? I can do that. So, the fraction left, right? The fraction left here is going to be 1/6 multiplied by 2/3 because it's 1/6 of your remainder from the start. All right. So 2 can go into this 1 time, 2 can go into this 3 times. So this is 1/9. So that's your fraction that is left. 1/9 is not used at all. But that corresponds to 120 beads. So the total beads at start right? All you need to do is invert that fraction, which will be 9, and you have to multiply that by the number of beads here, which is 20. So that's 180 beads. Okay, so that's the first thing I would probably do. I'll work out what is yeah, so that's the total number of beads that we started with. Now we want to work out how many more beads did she use to make the necklaces than handbands. Now there are 2 ways we can do this. We can actually work out the amount of beads that we use to make the handbands. We can work out the number of beads that we use to make the necklaces, and then we just subtract those 2 answers. That's one way you can go. All right, that's one way you can go. Or you can do it like this as well. So fraction actually, you know what? Yeah, I'll do it like this. Fraction for the handbands. Right? So the handbands would be 1/3 multiplied by the 180. So that's going to give you 60 handbands. Right? So for the handband, we're using 60 beads here. The fraction for what they call it here, the necklaces. Right, so the fraction for the necklaces will be 5/6 multiplied by 2/3. That's the fraction, right? And we're going to multiply that by the 180, okay? Because 5/6 multiplied by 2/3 will give me the fraction of the whole used for the necklaces. But if you want to work out the actual number, we have to multiply by 180. So we can do some reductions here. So this 2 can go into this 1. This here will be 3, right? So that's 3 by 3 is 9. So this and this will cancel. This will be 2. And this will be 100. Right? So basically, right? I'm going to change this word in here, right? Because what I've actually done, I've actually worked out the actual number of beads that we used to make the handband and the necklaces. So the question says, how many more beads? So the difference, right, is going to be 100 minus 60, and you're going to get 40. Right? I don't know if anybody got that. Right? Anybody else get 40 there? All right, great. Let's look at this one here. Megan and George purchased Avengers stickers, sorry, right? Avengers stickers. One-third of Megan's stickers is equal to 3/5 of George's. What common fraction of the total number of stickers belongs to Megan? What common fraction of the total number of stickers belongs to Megan? Can you all try to work this one before I work this one? Right, I've seen some people getting 14 over 15. So here's how we're going to work a problem like this. So 1/3 of Megan's stickers is equal to 3/5 of George's. All right. Now, when you have a question like this here, where we're trying to make a comparison, right? So 1/3 of Megan's is equal to 3/5 of George's. Now, the best thing you can do here, so 1/3. All right, so this is Megan, right? And this here is 1/3. Now, what they're trying to tell us here is that 1/3 of Megan's share is equal to 3/5 of George's. So we have George here, right? Now this 1/3 share, that's from here to here, all right, is equal to 3/5 of George's, all right? So that means that this here, right, sorry, this piece here, 4 George's, right, is actually equal to 3/5 of what he has, right? This here corresponds to 3/5. Now, for a question like this here, what I would suggest you do is we're comparing 1/3 and we're comparing 3/5. All right. Now, let's look at the denominator here. So what I'm going to do, the LCM of 5 and 3 is 15. So what I'm going to do, I'm going to write both of them as an equivalent fraction so that we can make a comparison here. So in this case here, if we put this over 15, all right, that means that you're multiplying by 5 here to get 15. So we have to do the same thing on top. 1 by 5 is 5, right? So this is 5 over 50. Then for the denominator now, right? Sorry, not the denominator. For the 3/5, get some space here. Let's write this over 15 as well. Right, so you multiply by 3 here. We do the same thing on top. Multiply by 3. So we're going to get 9 here on top. All right, so now I can make a fair comparison here. So what I'm going to do, because some of you all might have a little trouble visualizing this here. So Megan, right, in terms of stickers here, she has what it is, 1/3. So that's 5 over 50. So here's what I'm going to do. I'm going to write right, let's see how many I have here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. All right, so I have 15 shares here, right? I have 15 shares here. Now, what we're saying is that Megan, right, is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Right, so from here to here, this is the amount of stickers that Megan has, right? And that share there is actually equal to 3/5 of George's, right? So this here, from here to here, right, corresponds to 3/5 of George's, right? All right. So all we're gonna do, right? So the amount that George has here, right, is actually 9 over 15, right? This 3/5 here is 9 over 15, right? Let's not label this wrong here. We have to go up to 9 blocks. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right, so this here is 9. All right, I just want to make sure, more 1 second. It's equal to right, I've seen everybody saying, yeah, add the 9 over 15, right? Well, let's make sure we're doing that correctly, right? 1/3 of Megan stickers, right? 1/3, which is 5 over 15. So 1, 2, 3, 4, 5. Right? I'm just trying to find a best way to visualize this for you guys, right? Yeah, I'm just trying to find, give me one sec, right? Give me one sec, right? I want to be able to explain it in a way that makes sense to you guys, right? I do just want to just give you the answer. Give me one sec. Give me one sec. I just want to find a better way to explain this for you guys, right? Because there is an exam question that SCA brought a while back that came along these lines, right? They came along these lines here. Okay. Let me use, hold on one sec. Right? Because I don't want you to leave here and you're not fully sure what's happening, right? All right. All right, so let's use this for Megan here, right? I want to try to draw approximate diagrams here so you can see, right? All right, so that is Megan. Now George here, they're saying that 1/3 of Megan's stickers is equal to 3/5 of George, right? Let's get our next box here now. All right, now this here is actually equal to 3/5 of what George has, right? So if this is 3/5, 1, 2, 3, right? So that means that we need, right? 1, 2, 3, 4, 5. Right? So let's look at it from this perspective here. All right. So 1/3 is equivalent to 3/5 of what George has, right? So what I'm gonna do, let's break up this Megan's share. Let's break up Megan's share into fifths as well, right? Let's break this up into fifths here, right? So in this case here, right? So let's go. So this here could be broken up into 1/5, 1/5, 1/5, right? So each of her thirds, I can break that up into a 1/5, a 1/5, a 1/5, right? So what I have here now, that represents the total number of stickers that we have, okay? Now, if you want to work out what fraction belongs to Megan, right? You want to figure out what fraction belongs to Megan. As I've drawn it here right now, every block represents the same fraction. Every block here represents the same fraction, right? And in this case here, we have a total of 1, 2, 3, 4, 5 at the bottom, 6, 7, 8, 9, 10, 11, 12, 13, 1, 2, 3. Right, that's 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Right? I don't know if you all seen. Are you seeing 14 here? Is that making sense? All right. I hope that making sense. I feel like that not making sense to some of you all here. All right. So for this one here, we can see that Megan, right, is equal to the amount of stickers that Megan has here will be a total of 9. All right. And in this case here, the total number of equal parts that we have here is 9 and 5 is 14. But here what? You know what I will do? I will post the solution to this. I will try to find a better way, right? Yeah, I'll try to find a better way to explain this for you, right? What I will do, I'll post it on my Facebook page, right? I'll try to draw some diagrams here to help you understand this one better, right? Because I feel I'm not explaining this one the best, right? All right, I'm gonna switch to this next one here, right? I'm just gonna switch to this next one here in the meantime. So Eddie spent 2/7 of his money on a weed whacker, all right? 13/15 of the remainder on a lawnmower and kept the rest. If the lawnmower cost $1,400 more than the weed whacker, calculate the amount of money he had at first. Now again, this one is a kind of tricky one here. So we have Eddie, and he's spending his money on two things. He's purchasing a weed whacker, and then part of the remainder is being used to purchase a lawnmower, right? And he kept the rest. So again, with this one here, right? With this one here. All right, so we have a weed whacker and we have a lawnmower. So he spent 2/7 of the money. So this here will be 2/7. So if that's 2/7, it means what he's left with is 5/7. Okay, so 2/7 is spent on the weed whacker. I'm just going to put weed whack. Then he spent 13/15 of the remainder on a lawnmower and he kept the rest. So in this case here, what's happening here, we have this block, right? That's your remainder after he bought the weed whacker. And he's using 13/15, right, on a lawnmower. So this here will be 13/15. That's how much he's spending on the lawnmower. And then what you're left with will be 2/50, right? That's the remainder. So this here, this fraction here represents your lawnmower. Right? And this one here will represent what is left. Now the lawnmower costs $1,400 more than the weed whacker. Now this part here is where we need to be careful, right? That information they're giving me here is the difference in the cost between the whacker and the lawnmower. Okay? All right, so how are we going to do this one here? So the first thing, since this here represents the difference in the cost, what I should do, I should first find out what's fraction for the weed whacker. So the fraction for the weed whacker, right, is equal to 2/7, right? The fraction for the lawnmower, right, is going to be, now the lawnmower here, when we're looking at a fraction here, we're looking at the fraction of the whole. So we have to take 13/15, and you're going to have to multiply that by 5/7, right? And let's see what fraction we get for this here. So this 5 can go into this one time. This here will be 3. So that'll be 13/21, right? So that's a fraction of the whole that was used to purchase the lawnmower. Now what I will do here, that fraction for the weed whacker, let's write that as an equivalent fraction over 21 as well. So let's write this as something over 21. All right, so 7 multiplied by 3. Then 2 multiplied by 3 as well. So that's 2 3s are 6. So that's 6/21, right? That's 6/21. So the difference between these two fractions here will give me the difference in cost, really, right? So the difference will be, so you're going to take 13 over 21. So the lawnmower is costing more than the weed whacker, minus 6 over 21. So when I subtract this here, right, you're going to get 7, right, over 21, right, which is going to be 1/3. You all with me there? Right? So that's the difference. But we know what the difference accounts for. That difference there accounts for $1,400. So remember, we want to work out the money that he had at first. So the money at first is simply going to be equal to, so we have to invert. So this is going to be 3 over 1 multiplied by 1,400. Right? So that is 1,400 multiplied by 3. Right? So 4 3s are 12, 1 3 3 and 1 4. So that's going to be $4,200. Right? So yeah, I'm getting 4,200 as my answer. Right? I'm getting 4,200 as my answer. All right, guys. So this is all the time I have for this afternoon. All right. So I hope that the questions that I did were helpful. I really hope they were helpful. The second to last question, what I will do, I will try to post a visual on my Facebook page, right, explaining that question a little more. All right, I need to explain it a little better, all right, for you guys. All right, guys, so that's it for me for this afternoon. Enjoy the rest of your afternoon, guys. Be safe, right, and good luck with your studies, right? Take care, guys.